friends, this video on mechanical properties of fluids part 28 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos from part 1 to part 27 before going ahead with part 28.
Now we will understand another term called terminal velocity. What is terminal velocity? So all these terminologies, I am very sure that in this particular lesson, that is mechanical properties of fluids, you are learning a lot of new terms, new laws and new concepts. So it is very important that you remember each of them in an ordered way. Like when I talk of Stokes' law, terminal velocity, they all are related to viscosity, right? So please try to correlate things as we keep learning new things in the lesson. So what is terminal velocity? It is the maximum velocity of a body moving through a viscous fluid. As I told you just now, when a body moves through a viscous fluid, the retarding force also keeps increasing with the velocity of the body. So let us suppose any object, when it moves through a viscous fluid, if its velocity is increasing, then the retarding force will also keep increasing. So a stage will come when the velocity will stop increasing. So terminal velocity is the maximum velocity that the body can attain when it moves through a viscous fluid. That means the velocity cannot increase above that particular value. So terminal velocity is attained when the force of resistance of the medium is equal and opposite to the force of gravity. That is what I told you just now. That means initially the velocity of the body will increase. Now as the velocity will increase, the force of resistance or the retarding force will also keep increasing. So a stage will come when the force of resistance will become equal to the force of gravity. After that point, the velocity will not increase any further. That means that was the point when the body attained the maximum possible velocity. So the body attains maximum velocity when the force of resistance becomes equal to the force of gravity. Terminal velocity is generally denoted by Vt. The subscript T denotes terminal. Now we will derive an expression for terminal velocity. How do we mathematically express terminal velocity? So in order to get an expression for terminal velocity, we know that terminal velocity is attained when the net retarding force or when the force of resistance becomes equal to the force due to gravitational attraction, right? So according to Stokes' law, what is the force of resistance that a body experiences? It is 6 pi eta RV, where eta is the coefficient of viscosity, r is the radius of the object or the sphere, and v is the velocity with which the sphere is moving. Now what would be the force due to gravity? Let us suppose if this is the sphere, the gravitational force would be nothing but the weight of the sphere, that is mg, and this would be the retarding force. So this will be equal to mg. Now we can write it as 6 pi eta rv is equal to, what is mass? We know that density is equal to mass per unit volume. So we can write mass as density into volume into g, right? Now what would be the density of this sphere? If you see, as I told you, the medium is a viscous medium, right? So when the sphere falls through this medium, let us suppose the density of the sphere is rho and the density of the medium through which it is falling is sigma. So what would be the net density of the sphere? It would be nothing but rho minus sigma, where rho and sigma are the densities of the sphere and the medium respectively. So we can write it as density is rho minus sigma into V. Now what would be the volume of the sphere? volume of the sphere would be nothing but 4 by 3 pi r cube, where r is the radius of the sphere. So we can write it as 4 by 3 pi r cube into g. And on the left side, we already had 6 pi eta rv. So pi and pi will get cancelled. R will get cancelled with 1 r. So we will be left with this velocity v is equal to rho minus sigma into g 4 by 3 r square into 1 by 6 into eta. So we can cancel this. 2 2s are 4, 2 3s are 6. So this can be written as 2r square rho minus sigma into g divided by 9 eta. So this value of velocity is nothing but terminal velocity. So this is terminal velocity. So this will be our expression for terminal velocity. So here we can write the velocity is equal to terminal velocity when force of resistance is equal to the force due to gravity. So we equated both the equation and we arrived at this expression for terminal velocity. Now let us look at a problem based on whatever we have studied. The problem says, calculate the terminal velocity in air of an oil drop of radius 2 into 10 to the power minus 5 meters from the following data. G is equal to 9.8 meter per second. Coefficient of viscosity of air is 1.8 into 10 to the power minus 5 pascals second. Density of oil is 900 kg per meter cube. The upthrust of air may be neglected. So this is an oil drop which is falling in air. So this is air. So this oil drop is falling in this way. So we have to calculate the value of terminal velocity. So we are given the radius of the sphere as 2 into 10 to the power minus 5 meters. G is equal to 9.8 meter per second square. Coefficient of viscosity of air is 1.8 into 10 to the power minus 5 pascal second. Density of oil, that is rho, is equal to 900 kg per meter cube. Now in this case, upthrust of air is neglected. So when we derived the formula for terminal velocity, we introduced another term called sigma. So the sigma came into picture due to the upthrust of air. Now upthrust of air is neglected, so there is no sigma. So we can write down the expression of terminal velocity directly, or we can do it in this way. The weight which will be acting downward, or the force which will favor the motion, is mg. That is due to the weight of the oil drop, and the retarding force or the force of resistance will be in the upward direction. So terminal velocity will approach terminal velocity when the total resistive force, that is 6 pi eta rv according to Stokes' law, will be equal to mg. Now what will be m? Mass is nothing but density into volume. So this is density. And what would be volume? 4 by 3 pi r cube into g. So in this case, this v is nothing but vt. So vt will be equal to, so here we can write 6 pi eta r vt. So pi will get cancelled. This r will get cancelled and this will become r square. So Vt will be 2 into r square into g into rho divided by 9 eta. So now we will put the values which are given. 2 into r is equal to 2 into 10 to the power minus 5 whole square into g, that is 9.8, into rho, that is 900, divided by 9 into eta. Eta is 1.8 into 10 to the power minus 5. So this value comes out to be 4.36 centimeter per second. So this would be the terminal velocity of the oil drop. Now,
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.